Okay, so we're going to be doing some review of stoichiometry, and I've already had the other videos out, so I'm going to work you through a couple of the problems. We'll stop different pieces to kind of review and reinforce some things. Okay, with that, as you go through stoichiometry, the very first step in these problems, you have to have a balanced equation because you've got to have those mole ratios. So you go through, okay, grams of zinc react plus aluminum oxide. Excess just means that you got as much as you possibly could use, and that'll come in when we start doing limiting reactants. Okay, plus 3, oxygen minus 2. You sip compounds, we learned the trick of crossing down. Can't reduce, so we're good to go. Okay, so I've got this and this, got a single element, got a compound. Best I can do is single displacement. It already told me one of the things I'm making, zinc oxide. In a compound, zinc takes a +2 charge unless otherwise told. Oxygen's always going to be a -2. +2 minus 2 is 0. And then we have aluminum by itself. So we've got that. Now we got to go through and do the balancing. Well, 1 ZN, great. 2 ALs, 1 AL. I'm going to use a pencil in case I need to erase. 2 ALs. Now I've got 3 O's, 1 O. If 3 go in, 3 have to come out. Now I've got 3 ZNs coming out, 3 going in. Okay, that's review. You've been able to do that, not a problem. Now what we want to do is go through, and this is the process that I'll use. I know I'm starting with 43.7 grams of zinc. That's where I'm going. That's where I'm starting. I'm ending with grams of zinc oxide. So right now, the ones that I care about are those two. I don't care anymore about the aluminums. That was only there to get me the balanced equation. This is my focal point. These are the only things that should be in my calculation. Start with the given value. So I've got 43.7 grams of zinc. Put it over 1. So right now I can't do anything else there. And need to go through and figure, okay, what I've got to go from grams to moles because we can't do anything with grams. We've got to always have to have moles. So I've got to get rid of grams, dimensional analysis. That means grams have to go on the bottom. Just got done saying grams need to go to moles. That's the only thing we can really do with grams is go to moles. And grams ZN, grams ZN. This is kind of important because you're going to be changing substances within this process. So go through, and whenever we convert from grams to moles, it's always 1 mole. And that's an infinite number of sig digs, so we're saying it's exactly 1 mole. It's not a portion. Okay. So down here, you have to have the molecular mass of the substance, because if I have the molecular mass of that substance, it equals 1 mole. So I've already done some pre-work here, and I went through, and remember this sheet's available online, easy enough to get. So 65.4, 16.0. Now I've got to figure out where my answer ends. And you guys have seen me do this before. I use the colored pencils. Figure out which one is furthest left. That's where my answer drops. Well, it just so happens that they're in the same spot. So I would take the mass of 81.4. I do that because it will not always be 3 significant digits. When it says only 3 sig digs here, that means this box, when you multiply across, you can only get 3 sig digs. Because sometimes this will be 4 or more. You've got to cut down. So mass, 81.4. So what this says, if I have 81.4 grams of zinc in one place, I've got the equivalent of 1 mole. My grams of zinc are gone. The only thing I have left right now are moles. Moles of zinc. But I don't want zinc. I don't want this. I want this. So I've got to be able to convert from this substance to this substance. And that's stoichiometry. And how we make that happen is the mole ratio. Back to dimensional analysis. I have moles of ZN. I don't want it. So I see it on the bottom of the next one. Thing I'm looking for goes up top. And we're always convert mole to mole because that's what our ratio is based in. And go through and look at the next piece of what is my relationship between moles and moles. So I'm going to look at the coefficients in front of those compounds. So in this case, it's a 3 in front of ZN. It's a 3 in front of the ZNO. So it takes 3 moles of this to make 3 moles of this. There's my ratio. Moles of ZN are gone. So now I have moles of ZNO. Now, I could stop there. If the problem just asked me for moles of ZNO, I could stop there, and that's the only unit I have left. Okay, easy enough. If for some reason it wanted me to go into moles of the zinc ion, I could have just done that, or it'd be Zn plus 2. Okay, same process. But in this case, it wants me to go to grams. So I've got one more step I have to do. I'm in moles. I don't want moles. Dimensional analysis means, hey, I got to have it on the bottom here because it has to cross cancel. Thing I'm looking for is going to go up top. So it's going to be grams ZNO. The mole value is always going to be 1, infinite number of sig digs. And now we've got to get the molecular mass of ZNO. Hey, well, actually, just realized I'd already calculated the molecular mass of ZNO over there. And this one, I jumped out on myself. Molecular mass of zinc, 3 sig dig, 65.4. Sorry about that. At least we got it. Okay, so if I can get 81.4 grams of ZNO in one spot, I have 1 mole. Now all I do is just the molecular mass. And remember, I always recommend doing calculator value first. Punch that in like until you get the same answer 3 times. That way you can catch any errors. Then go back and adjust for sig digs. I've got 3 here, 3 here, infinite. These are mole ratios. So we're saying it's exactly 3 moles here, exactly 3 moles here. There's infinite, and there's 3. I'm looking for the lowest number. It's 3. So 1, 2, 3, draw my line. Again, that's how I run it. I look one spot to the right. It's 5 or greater, so that means it's going to round up. My final answer becomes 54.4 grams of ZNO. Once again, could have stopped here at moles. I actually could have started at moles and gone to ZNO. That could have been 32.1 moles or 3.21 moles, whatever. And I would have still run the same process here. But normally we have grams to grams. We have grams in the laboratory, and we'll go to grams of something else. We're trying to figure out how much we're going to make. So with that, stoichiometry, those problems work pretty much the same each time. First step, you're always going to have a balanced equation. Then you're going to have to convert from known substance into moles of the known substance. You got your mole ratio. You got your moles to the grams of the new substance, and then you just solve it. That's a set pattern. Okay? So real quick, we're going to work out another one because there's one thing I wanted to show you, and may not be what you think. Okay, so we're going to jump down here to the very bottom one. 621.2 grams calcium phosphate reacts with iron 3 acetate. How many grams of iron 3 phosphate are produced? So go ahead and get your stable compounds. I'm going to shortcut it with the assumption that you guys could do this on your own. So there's my 2 reactants. I actually told you I was making this. I didn't have to tell you. You could have figured it out from there. Okay. So iron says it's a +3 charge. Phosphate's always going to be a -3. So what's left? Well, I've got calcium and I've got acetate. You should be working on getting these polyatomic ions memorized because you're going to need them. Okay, so go through and balance. I'm going to use regular pencil right now. I've got 3 CAs, 1 CA, so I'm going to put a 3 there. Okay, I got 2 PO4s. I've got 1. What goes in must come out. If 2 go in, 2 have to come out. Now I have 2 FEs coming out. That means I had to have 2 going in. 2 times 3, I have 6 acetates going in. Hey, 3 times 2 is 6 acetates. I'm now balanced. Now, focus on what we've got. Well, I've got calcium phosphate, so I'm going from this into iron phosphate to this. I'm not using the same metal. I'm going into something different. Okay, I don't have to always go to a calcium compound. I can go to any compound over here. In fact, I could go from here, say if I've got this much, how much of this do I need to react? Stoichiometry can go from anywhere. Or if I need to have this, how much going in? If I only need to have 60 brownies, I can figure out how many eggs I need based on the recipe. And that's basically your recipe. So go 621.2 grams. And you're going to see in a second why I wanted to do this one. I've got grams of one, I've got to get grams of the other. The only thing that allows me to make that change is our mole ratio. So dimensional analysis, I've got to go from grams to get into moles. So whenever we convert into moles, it's always a 1 mole value. So now here's the reason I wanted to go through and do this. I need to get the molecular mass of calcium phosphate. So going through here, once again, this is a sheet. I kind of broke it up so it kind of walks you through the step. Number of atoms. Well, I've got 3 calciums. Phosphates, well, in that, I only have 1 phosphorus. Well, I've got a 2 out here, so that means I'm actually going to have 2 phosphorus because it multiplies through. Well, 2 times 4, that means I've got 8 oxygens. So here's the piece. 3 times 40.1, that means the calculator, the dumb machine, is going to spit out this. Okay. That is 4 sigdics. I only want 3 because the rule is it's always based on the least number of sigdics. Infinite, you have an atom or you don't, 3 sigdics. So this needs to cut to 3 sigdics. Well, 3 can't round, that means it drops, but that was a real 0. So you got to kind of keep in mind that is a real 0. Okay, my notations always put a line under it. Okay, 2 times 31.0, 62.0. And then we have 8 times 16. Should be able to do that in my head, but I can't. So 128, 3 sigdigs there. Copy that over. So with that, going through, I usually do this on the calculator just so I can trust my brain. My calculator spits out 310. I want to double check it. Okay, 310. That way I can catch if I made a mistake the first time. Now going through, I need to figure out where my answer ends. We said that 0 is real. Put a line there. That 0 is real because it's ending 0 after the decimal. And then that 8's real. Okay. Find the mark furthest left. That's the blue and the green. Drop that. So it cuts right there. That means my answer, final answer, is going to be 310. But the thing is this. That was a real 0. That's a real 2. That's a real 8. When I add 2 and 8 together, it's exactly 10. What that means is that 0 is real. That means there are 3 significant digits there. But if you just saw 310 by itself, you'd say, okay, there's only 2, but there's actually 3. So you gotta be careful of that. Once again, I put a line under it as a notation. Okay, grams, calcium phosphate's gone. I'm in calcium phosphate. I've got to get into iron phosphate, so I use my mole ratio. And this is why I say, hey, put those formulas in because you need to know where your switch substance is. Look at the values in front. So this is the same for every one of these. You're going to make 2 of these. Dimensional analysis. Now I'm in moles of FePO4. I need to get to grams. Well, last step. I've got moles. Got to get rid of it on the bottom. And then going to go to grams. Remember, in AP, they're not going to be put in parentheses unless there's multiple of them. So I'm going to start working on not doing that for you. And through the magic of television, I'm going to tell you that the mass of iron phosphate is 150.8. If I do the math on this, my calculator would spit out that. Now I've got to go back and look at my sig dig values. Well, I've got 4 here, infinite, 3 because that 0 is real. These are infinites. That's infinite, and there's 4. So my smallest number is 3. 1, 2, 3. That would be where it cuts. Can that round? Nope. So it's all gone. So that means my final answer is going to be 604 grams of FePO4. Okay. So once again, I could have stopped at moles, okay, and have an answer. It would have ultimately led when I had the molecular mass. I could have started with moles. I could have started with moles and ended with moles. I can do any combination within that. That's stoichiometry. It's changing from one substance to the other. So hopefully that makes sense. I am going to put into your notebook a step-by-step I created. So mass, stoichs, and also has moles in case you're confused. I've given you examples, walk you through the step-by-steps. So hopefully that'll help. Go from there. Good luck. Have fun.